Auzu billahi minash shaitani rajim. Bismillahir rahmanir rahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you will come back to this study. Till now, what we have done, let's call them first. For the course Applied Linear Algebra, in the previous lecture we have done introduction to matrices, type of matrix and matrix operations. Now next topic which we are going today is echelon and reduced echelon form of a matrix, and this is the first lecture for second week. Now what is row echelon form and reduced row echelon form of a matrix? A matrix in row echelon form has these properties. Number one, in each successive non-zero row, the numbers of zeros before the first non-zero entry of a row increase row by row. And the second property, every non-zero row precedes every zero row if there is any. And the matrix in reduced row echelon form has the following these two properties. It is in row echelon form, and number two, the first non-zero entry in Ri row lies in Cj column is 1, and all other entries of Cj column are 0. Now let's move on an example. Suppose this is a matrix. This matrix is in row echelon form because number of zeros increase row by row before the first non-zero entry in each row. This is the non-zero entry in this row, and before this non-zero entry there is only 1 0. So this is the non-zero entry in this row, and before this non-zero entry there are 2 zeros. So number of zeros in each row increase row by row before the first non-zero entry. So this matrix is in row echelon form. Similarly, this matrix also in row echelon form because the number of zeros in each row increase row by row before the first non-zero entry. In this row, in this second row, this is the non-zero entry, and before this non-zero entries there are 2 zeros. Similarly, in this row, this is the non-zero first non-zero entry, and before this first non-zero entry there are 3 zeros. Similarly, this is the first non-zero entry of this row, and there are 4 zeros before this non-zero entries. So this matrix is in a row echelon form because number of zeros before the non-zero entries increase row by row in each row, and this matrix is not in row echelon form. Similarly, in this matrix there is this is the first non-zero entry, and this non-zero, and before this non-zero entry there is 1 0, and this row, this is the non-zero entry, before this non-zero entry there are 2 zeros and there are 4 zeros. So the number of zeros increase row by row. So this matrix is in echelon form, and since in this matrix this is the non-zero entry, and in this column all other entries are 0. Similarly, in this row this is the non-zero zero entry, and all other entries in this column is 0. Similarly, in this column this is the non-zero entry, this is the 0 entry. So this matrix is in reduced row echelon form. Similarly, this matrix also in reduced row echelon form. This is the first non-zero entry. In the second row, this is the first non-zero entry, in all other entries before this non-zero entry is 0. Similarly, this is the non-zero entry, in all other entries are zeros, and in this row this is the non-zero entry, and in this column all other entries are 0. Similarly, in this column this is the non-zero entries, and other entries are 0. Similarly, in this column, this is the non-zero entry, and other entries in this column is 0. So this matrix is in reduced row echelon form. But this matrix is in echelon form but not in reduced echelon form, since all other entries above the leading one in this third column are not 0. And this matrix are not in echelon form because this is the first non-zero entry, this is the leading one, and before this leading one there is only 1 0, and in this row this is the leading one, this is the leading non-zero entry, and before this non-zero entry there is only 1 0. Number of 0 does not increase, so this matrix not in echelon form. So definitely this is also not in reduced echelon form. Now for the echelon and reduced echelon form, we need some row or column operations called elementary row operations or called elementary column operations. Now what are elementary row operations? There are 3 elementary row operations. Number 1, we can interchange any 2 rows represented by Ri interchange Rj. Number 2, multiply a row by some non-zero scalar k represented as Kri. And number 3, add a multiple of a row to another row represented as Ri plus Krj. Now let's move on example echelon and a reduced echelon form of a matrix. This is a matrix, and we want to create the echelon form of this matrix and reduce echelon form of this matrix. For the echelon form of matrix, we need to make these 2 numbers and this number 0. Dear students, start your work in this direction. First, make this 4 0 and this 6 0. To make these 2 numbers 0, we need some elementary operation. For example, multiplied R1 to 4 and this subtract from second row. We get 1 2 3. This is the first row and this is the second row. Multiplied 4 to the first row and then subtract to the second row. Multiplied 4 to the first row and then subtract to the second row. Multiplied 4 to this number and then subtract from -6. Now to make this number 0, we multiplied 6 to the first row and then subtract from the third row. Multiplied 6 to this row and then subtract from the third row. 6 from the 6, so 6 minus 6, and 6 to the 12, so 7 minus 12, and 6 to the 18, so 8 minus 18, and we get the new matrix 1 2 3 0 minus 3 minus 6 0 minus 5 minus 10. Now we need to make this number 0. So multiplying R3 by minus 1 over 5 and multiplied R2 by minus 1 over 3, we get this matrix. Now subtract R2 from R3, we get this matrix which is in row echelon form. Now to reduce row echelon form. For the reduced row echelon form, in this first row this is the leading one and all other entries in this column are 0, and in this row this is the leading one, but all other entries in this column are not 0, 2 is not 0, so we want to make this number 0. To make this number 0, multiplied R2 by 2 and then subtract from R1, we get 1 0 minus 1 0 1 2 and 0 0 0. So this is the reduced echelon form of the matrix. Now here is another example. This is the matrix A 4 5 6 1 2 3 and 7 8 9. We want to row echelon form of this matrix. For the row echelon form of this matrix, again we need some elementary row operations. For example, interchange R1 in R2, we get 1 2 3 4 5 6. Interchange first row and second row, we get this matrix 1 2 3 4 5 6 7 8 9. Now for the reduced echelon form, we want to make these two numbers 0 and this number 0. To make these two numbers 0, start your work in this direction. First make 4 0 and then 7. So multiplying R1 by 4 and subtracting from R2, we get this result 0 minus 3 minus 6. And now to make this 7 0, multiplying the first row by 7 and subtract from R3, we get 0 minus 6 minus 12. Now we want to make this number 0. For this purpose, multiplying R2 by 2 and then subtract from R3, we get 1 2 3 0 1 2 and 0 0 0. This is the row echelon form. By using row echelon form, we can find the rank of a matrix. For example, in this matrix there are two non-zero row, and this is only the 1 0 row. So the number of 0 in echelon form of a matrix is called rank of a matrix. So the rank of this matrix is 0. This is the definition of the rank of a matrix. The number of non-zero row in echelon form is called rank of matrix. So in this example, in the previous example in which I have already discussed, in this example again I want to repeat, there are two non-zero row in echelon form. So the rank of this matrix is 2. And this is the end of this segment. Thank you. Allah Hafiz.